let's do magnetic force on moving charges 9. An alpha particle is a helium nucleus that consists of 2 protons bound with 2 neutrons. Its mass is 6.644 times 10 to the minus 27 kilograms. An alpha particle moving through a perpendicular magnetic field of 1.4 Tesla experiences an acceleration of 2.4 times 10 to the 3 meters per second squared. Part A, what is the force on the alpha particle? And part B, what is the alpha particle's speed? Okay, so this question is nice. It actually sets it up for us how to find part B through part A. But expect sometimes you might just be given a question that you're going to go straight to part B, okay? So what is the alpha particle speed? You know, I'm just going to start from there because really that's a better problem here. What's the speed of the particle? Well, this particle is entering through a magnetic field, so we know that there's going to be a magnetic force acting on it, right? There's going to be a magnetic force QVB sine theta. Now, we are told that it's moving through a perpendicular magnetic field. It's moving, so that's the velocity, perpendicular magnetic field. That means the velocity and the magnetic field are at right angles to each other, right? So that means theta is equal to 90 degrees, and we know in the formula we're taking the sine of theta. Sine of 90 is equal to 1. Okay, so that's your maximum magnetic force there. Okay, so sine is equal to 1 because we have 90 degrees. Now, the question in part B is asking us for the speed. So rearranging this formula for speed, divide left and right side by QB. So it becomes FB over QB. So this doesn't seem so bad, right? Well, what's the charge here? It's an alpha particle, right? So an alpha particle has 2 protons, 2 neutrons, right? So the charge is going to be from the 2 protons, right? Because neutrons are neutral. They don't have any charge, or you can say they have charge 0. But the protons are going to be what gives the charge. Well, each proton has a charge of E, right? The electronic charge, and I have 2 of them. So I have 2E. Now, if you remember, E is 1.602 times 10 to the minus 19 coulombs. If you don't yet have that memorized, I would certainly commit it to memory, okay? But anyways, here it is. We can always calculate what this is after. B, we know the magnetic field strength. It's 1.4 Tesla. What we're missing is the force, okay? So you've got this alpha particle moving through. What forces are acting on it? I mean, you've got the gravitational force, certainly, right? But really, it's so insignificant. I mean, look at that mass, times 10 to the minus 27. You multiply that times 9.8, you're not really getting anything significant. This is a very, very small number. It's not going to affect this whatsoever. So we can ignore gravity, actually, for this case. So we can assume that, actually, the net force acting on the particle is simply the magnetic force. Okay, so if we assume FB to be F net, then we can set FB equal to MA. Okay, now what's the mass of the alpha particle? Well, okay, now the mass is going to come from the 2 protons and the 2 neutrons. So be careful because neutrons might not have a charge, but they certainly have a mass. Okay, so the mass is given to us as this, 6.644 times 10 to the minus 27 kilograms. So 6.644 times 10 to the minus 27 kilos. We're even given the acceleration, 2.4 times 10 to the 3 meters per second squared. Okay, so when you crunch that out, when you punch it in your calculator, you're going to get a net force of 1.6 times 10 to the minus 23 newtons, approximately. Okay, so here's my FB, which is also known as my net force. Okay, so that gets plugged in over here. Okay, so FB is equal to 1.6 times 10 to the minus 23 newtons divided by my Q, right, which is 2 times 1.602 times 10 to the minus 19 coulombs times B, well, B is 1.4 Tesla. Okay, so there I go. So crunch this in your calculator, punch it in, and you're going to get a speed for the alpha particle, 3.6 times 10 to the minus 5 meters per second. And that's it, guys. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me. Stay tuned next time for video 181, Magnetic Force on a Current Carrying Conductor 1.